Hello. I just want to do a quick recap video of the lesson that we did previously before we started distance learning. I think on that Friday right before we left, we were doing factoring quadratic trinomials. So just want to do a quick video to recap the same PowerPoint that I showed in class. So quadratic trinomials, remember quadratic means your highest degree is a 2. Trinomial means you have 3 terms. So this is a quadratic trinomial. Um, Now, in order to factor these, you need to know how to do factor by grouping. So factor by grouping, if you remember, only works with 4 terms. Now we're going to connect these two in a second because this has 3 terms and now I'm saying 4 terms. So we'll see how those two connect right now. Well, not right now, but right after I do this. So factor by grouping, you need 4 terms for factor by grouping to work. What you do is you think of the 4 terms as 2 different groups. So you just break it up into a first group and a second group. Um, then what you do is you basically take a GCF out of this first group. So the first group has an x times an x is an x squared, 4 times x is 4x. Take out whatever they have in common. These both have x's, and then your leftovers are the x and the positive 4. This is positive because up here we had a plus 4, so that must be a plus. Now, I showed you a shortcut for this other part. The shortcut was you would take this x plus 4 group and put it over here and then just figure out what number would have to be in front of the x plus 4 group to make a 5x plus 20, and hopefully you can kind of imagine that's a 5. The PowerPoint kind of shows it the longer way. So the longer way is you just take the GCF of these two parts. They both have a 5, pull a 5 out, and then your leftovers are an x plus 4. So if you notice, if we did this in a little bit different order, if I had an x plus 4 here, I would write my x plus 4 over here. I wouldn't see this 5 yet, so I would just see x plus 4, figure out the number that would be out front that would give you the 5x plus 20, and it must be a 5. So 5x, and then 5 times 4 is 20. So now we pull another GCF move, greatest common factor move, because I have an x plus 4 on this first part and an x plus 4 on the second part. So since those are in common, I can pull them out of both parts, and then my leftovers, just like I did before, go inside of parentheses, and I am done factoring. Okay, so in order to connect these two, basically um, take a look at these next polynomials that we got on here. So we got a 1, 2, 3, 4, 5 of them, all different colors. Feel free to pause the video, take a look at these, see what you can notice they have in common. Okay, so what they have in common are the middle term. So if you look at this trinomial, I'll get a 13x in the middle. So 8x plus 5x is 13x, 3x plus 10x is 13x, 6x plus 7x is 13x, 2x plus 11x, they're all 13x. So technically every single one of these are the exact same expression. But only one of these 4-term expressions is, are you able to factor by grouping? And without having you try them all, I'll go ahead and tell you that it's going to be this blue one. So this blue one is actually the only one out of all those other ones that you can actually factor by grouping actually works with. If you try to factor this by grouping, you're not going to be able to find the same group. Same thing here, same thing here. So the blue one is the only one that we're able to work with. Now the question becomes, all right, so I know that it only works with this 13x, but 13x could have been split any number of ways. Could have been 8 and a 5, 6 and a 7, 2 and 11. So how did I pick 3x and 10x? So that's what this next method is going to be. Figuring out, okay, I can't factor this 3-term polynomial by grouping. So how do I make it into a 4-term polynomial that I can factor by grouping? So if you notice, the only difference is the middle term. So what we're going to practice right now is doing this. So we have 2x squared plus 13x plus 15. I know I want to make it into this blue one because this blue one is the one that can actually be factored by grouping. Now, ax squared plus bx plus c, this is your standard form of a quadratic. Don't worry too much about all that verbiage right there. Basically, I just want you to see that your a is the 2, b is 13, c is 15. That way, if I say, hey, what's b? You know I'm saying it's a 13. If I say c, it's a 15, a is a 2. So a is in front of x squared, b is in front of x, c is just a number by itself. All right, so the process goes, I need to figure out 2 numbers. So that's why we have these 2 blank boxes. because I'm basically splitting this 13 into a 3x and a 10x. So I need to figure out how to split this 13 into two numbers that multiply to be a times c. So if I look at this, that's a 2 and a 15. So, and then add up to be this middle term of 13. And then we're going to practice this some more. So multiply to be 2 times 15 is 30, and then our middle term is a 13. So I need to figure out two numbers that multiply to be 30, but add up to be 13. So I can just, usually what I do is I go through the factors of 30. Now you can list them all out. Basically it's, these are all the factors of 30. 1 in 30, 2 times 15, 3 times 10. Now if I look at 1 in 30, that multiplies to be 30 but is not going to add to be 13. That's going to be a 31. 2 and 15, that multiplies to be 30 but that does not add up to be a positive 13. 3 and 10 multiplies to be 30 and they add to be 13. So must be a 3 and a 10. Now one part though, just make sure you keep an eye on your negatives because they will pop up sometimes. 2 and 15, 15 minus 2 is a 13, but if one of these was negative, this would be negative. So we'll see that some more in some later examples. Everything's positive on this example though. So, all right, so we got a 3 and a 10. Now if you notice, that's exactly what I wanted, was a 3x and a 10x. So there you go. That's the process to figuring out how to split this middle term into a 3x and a 10x instead of like a 10, or sorry, 11 and a 12, all right, or an 8 and a 5. So that's basically what we're going to practice now. So we're going to practice splitting that middle term. If I was a great programmer, I'd do some kind of app, but I'm not, so we're going to do this through our PowerPoint. So you're going to get all kinds of quadratic trinomials, so 3x squared, 20x, and 12. Now the first thing you should always check for is if there's a GCF, if you can take out a number out of all three of these terms, because it can make your numbers a lot smaller and easier to work with. In this case, a 3 and a 20 and a 12, there's no number that goes into all three of those nice and neatly. Well, there's numbers, but they're decimals. So let's go ahead and figure this out. So first step, now this x thing that we have over here is to help organize our thoughts. So first step is 3 times 12, a times c, which is 36. And then I'm going to take this 20 and then put it at the bottom of this x. And again, this x is just helping you organize your thoughts. You don't have to write it. You just have to know in your head that it has to multiply to be 36 and add up to be 20. Okay. Now, if you go through the factors of 36, you get 1 in 36, 2 in 18. Turns out 2 in 18 make that 20, so you can stop at 2 in 18. So you get that. If you try this one, give you a little bit to try it out. See if you can come up with two numbers that multiply to be 6 and add to be 7. Feel free to pause the video at each one of these. I'm going to go through it kind of fast, so pause the video at the start and then see if you can come up with them. Should be 1 and 6. Then you're going to rewrite it as a 4-term polynomial. Okay, let's try this one. Top and bottom should be negative 20 on top. Now b is usually the number in front of x, so that's going to be a 1. And that's going to be a negative 4 and a 5. Okay, so negative 4 times 5 is a negative 20. Negative 4 plus 5 is a positive 1. Okay, and this one, let's see if we can do the setup. Should get a negative 45 and a negative 12, and that would give you a 3 and a negative 15. Then split it apart. Okay, try another one. Like I said, we have positives and negatives going on here. So 5 times 2 is 10, negative 7 on the bottom. How can you multiply two numbers and get a positive, but when you add them, you get a negative? That only happens when they're both negative. Negative times a negative is a positive. Negative 2 plus negative 5 is a negative 7. So lean on your calculators if you know your positive negative skills need a little bit of work. And I think this is the last one. So x squared plus 5x minus 50. Keep in mind there's always a 1 in the front. If there's nothing in front of the x squared, there's a 1. So 1 times negative 50 is a negative 50. Then you get a 5. So that's a negative 5 and a 10. Negative 5 and a positive 10. It's going to split up like that. Okay. And, oh, wait, no, we got one more. So try this one out. Okay, should get a 36 on top, negative 15 on bottom. That's a negative 3 and a negative 12. Okay. And again, you would just list off all the factors of 36. You know they have to add to be a negative 15, but multiply be a positive, so they should both be negative factors. So a negative 1 and a negative 36, and then you just keep trying those out, okay? All right, so it splits apart, and now, so this goes back to the first example we were kind of looking at. So now we would have 4 terms. Once we split it apart, the trinomial split apart into this 4 term, and then you just start doing the factor by grouping again. Okay, so again, 2x squared and 10x, those break into you can pull a 2x out and a 2x out of that one. So because 10x is 2 times 5 times x, so that's kind of like in a different order than we're used to writing it. But it doesn't really matter the order. This is just another way to do it. So 2x, and then x plus 5s are left over. Again, you don't have to do this side like this. You can just say, okay, I got an x plus 5 group over here. What number has to be outside for the x plus 5 group to make the 3x plus 15? And it should be a 3, okay? This PowerPoint just kind of shows the steps on both sides, but since you need the same group on both sides, so it makes sense that once you find the first group of x plus 5, just write it over here, and then figure out what number has to be out here to get you back up to the 3x plus 15, and it must be a 3, because 3 times x and 3 times 5 gets you that. Now we're going to do another GCF, so x plus 5s are the same, so that pulls off, and then your group of 2x plus 3 gets thrown into there. Now, another way that you could do the factor by grouping is with a box. You don't have to do the factor by grouping. You can use a box like this. So this is the same 4-term polynomial. You'd basically just make a generic rectangle. So you got 4 boxes for your 4 terms. You're going to throw each one of these terms inside of one of those boxes. 3x and a 15. Then, just like we did on the previous example, we are going to factor all of these down. Okay, so 2x squared is 2xx, 10x is 5 times 2 times x, 3x, and a 3 times a 5. So now what we're going to do is we're going to pull common factors out front, very similar to factor by grouping. You look for what they have in common. So these 2 boxes have a 3 in common, so pull that 3 out. Now, keep in mind it's not a 3 times a 3, so it doesn't become a 9. It's just that for everything that they have in common, you're just going to pull that out as a single 3, okay? Now we're going to move up to these 2 boxes. I have a 2 and an x. Comes out. And now I'm going to go up. So what do these 2 boxes have left over? Now, when you're doing this on a piece of paper, I would, as I pull them out, since, you can't really, literally pull them out of the boxes, just cross them off as you're putting them out. That way you don't confuse them as happening again. And these 2 boxes have an x, and these 2 boxes have a 5 left over, because that's all they have. Now, once you're done with this process, there should be nothing left in your boxes, or everything should be crossed off. If not everything is crossed off, then you got a little bit of a problem. Now, this box method gets kind of funky with negatives. The negatives, you need to see what this box is that's right next to the factor you just pulled out. So if this was like a negative, say this was a negative, let's see, this would be the 10x. So say this was a negative 10x, this would be a negative 5. So whatever box is closest to it, whatever that number in there was, positive or negative, that's what you pull out. Now that's one reason why I personally prefer the factor by grouping over the box method, only because the negatives on the factor by grouping makes a little bit more sense than this one. But basically you would just take these and then put them in parentheses, and then you get the same answer as we did as with the other method. Okay, so just a quick recap. Steps for factoring quadratic trinomials. First, check for GCF. Always check for GCFs. Split the middle term using the x method. I guess you can call it a method, the x, to help you organize your thoughts. And then once you have split the middle term, you'll have 4 terms. Then at that point, you factor by grouping or using the box. All right, so what we're going to do now, by we I mean me, or actually no, by we I mean I'll do it and you should follow along, is I'm going to go on the dot cam and go over some example problems so you can kind of see what it looks like if you were to do this on a homework assignment. Okay, so oh, that's my dog. Um, I have a trinomial and it's a quadratic. So taking a look at this thing, first thing I'm going to do is I'm going to make my x. Well, actually, first thing, check for GCF. So 2, 3, and 20, they don't have any number that I can pull out that's in common. So I'm going to make my x. A times c, so 20, negative 20 times a positive 2. So positive 2 times a negative 20 is a negative 40. Okay, and then I got my negative 3 as my c term. Okay, so now what I'm going to do is I got to figure out some factors of 40 that could add up to be a negative 3. Now, what I like to do is just start with 1 times 40. Now, just think of, could I add or subtract these? Don't worry about the signs yet. Just think, can you add or subtract a 1 and a 40 to make a 3? So 1 plus 40 would be a 41. A 40 minus a 1 would be a 39. So that's not going to work. Okay, so now 2 and 20. That's going to be 22 if I added them. That would be 18 if I subtracted them. So that's not going to work. 3 doesn't go into 40 nice and neatly. 4 does. So 4 and 10. That adds to be a 14. Subtracts to be a 6. Neither one of those make that. So 5 times 8. 5 plus 8 is a 13. But 8 minus 5, I am able to get a 3. But the problem is I need a negative 3. So to make a negative 3, it looks like I should probably make the 8 a negative. 5 minus 8 is a negative 3. 5 times negative 8 is a negative 40. And there you go. I got a 5 and a negative 8. Okay, so that's the x part. So now what we're going to do is split this into 4 terms. So you have a 2x squared. You have a positive 5x. You have a negative 8x. And you have a negative 20. So that 3x broke into those 2 parts. And that arrow's kind of funky. Sorry about that. So the next part is I'm going to go ahead and factor these first 2 parts right here. So that's going to be a 2 times an x times an x. That's going to be a 5 times an x. Okay, factor by grouping, so I'm not worried about this other side yet. These two have an x in common, so x comes out. And that's it. So I have a 2x plus, because there's a plus here, 5. Okay, now my other group. This is what I was saying before. It's a little bit of a shortcut, because now I got to do these 2. So 8x minus 20. Instead of breaking it apart like this, I'm just going to take my group, the 2x plus 5, since I know that these groups need a match for this to work. Now I got to think of a number that's out here that can bring me back up to a negative 8x minus 20. So what times 2x is a negative 8x? And what times 5 is a negative 20? Okay, I would think a negative 4. So negative 4 times 2x is a negative 8x. Negative 4 times 5 is a negative 20. And there you go. So that's why I was saying I like this a little bit better than the box method, only because I got my negative pulled out and it's already accounting for all the negative stuff. Okay. So these 2 groups are the same. So I'm going to take out my 2x plus 5. And my leftovers are this x and this negative 4. So I'm going to put those inside of parentheses. And I am done. And you are done too. Okay, so let's do one more example. And again, if you feel like this is going a little bit fast or you need to slow me down, in class you would raise your hand and ask questions or just ask me to slow down. On here, just hit pause. You control the pace when you are doing distance learning. Okay, so taking a look at this thing. Now, I could go into the x right away, but you should always check for GCF first. So like over here, check for GCF. That's what we should always be doing, because right now if I do 10 times 60, I'm going to get 600. So when I start making this x thing, I don't want to put 650. There's a lot of factors of 600 and I don't want to go through all of them. So double check and make sure that you can see if you can take out a GCF. So a 10, a 50, and a 60. It looks like I can pull a 10 out of all of those. So that will leave me with x squared plus 5x plus 6. Okay. Um, Now, if you wanted to, you could prime factor each one of those. That way you can see all the stuff that comes out, but it'll come out like this. All right, so now, since I was able to pull out a 10, I'm going to ignore the 10 and act like this was my original problem. Okay, just x squared plus 5x plus 6, because I already pulled this out. I factored this out. So at the very end, I'm going to write 10, and then I'll just make 2 parentheses because I know that everything is ending up looking like this. If I look at my previous example and the ones that we did before, it was 2 sets of parentheses when I'm factoring this thing out. Okay, so I accounted for my 10. Just do that right away so you don't forget to write it in your answer. And now, like I said, we're going to act like this is just this problem right here, x squared plus 5x plus 6. Okay, so if I think about the a, I still have a 1 in the front, so I don't count that 10 as my a. Okay, it's the number in front of x squared, not outside the parentheses. So 1 times 6 is 6, and then I got my 5. All right, so now let's go through some factors of 6. I got 1 times 6. Now 1 plus 6 is a 7, 6 minus 1 is a 5, but this isn't going to work because if I start doing negative signs, like say I did a negative 1, that negative 1 times 6 is a negative 6, and it has to be a positive. So the only way to make this work is if they're both positive or both negative. That's the only way you can multiply to get a positive. So this isn't going to work out, because even if I switch it around like that, that's still not going to work. If I make them both negative, then I get a positive, but then that should be a negative 5. So that's not going to work at all. Okay, so I got 2 times 3. 2 plus 3 is still 5, so that looks like it works out. And 2 times 3, both positive, gives you that 6, so it must be 2 and 3. All right. All right, so remember, right now, we are just working with this part. Okay? The 10 already came down, so we're not even going to worry about that 10 anymore. So this is going to break apart. So I get x squared plus 2x plus 3x, and then I'm going to bring down this plus 6. All right, and then now we're going to do another factor by grouping here. So the first group is x times x, 2 times x. They have an x in common, so I'm going to pull an x out, and then I get an x plus 2. So they had an x in common. Took out x plus 2. The other side, I know that I need another x plus 2 for this to work, because these two groups need to match. So what number is out here that could multiply back in to get a 3x plus 6? Must be a positive 3. All right, and now I'm actually done. So I'm going to pull out the x plus 2's out front, and x plus 3 over here. And just a quick comment, if you put x plus 3 on this side and x plus 2 on this side, it's still the same thing. Multiplication is commutative, so like 5 times 3 is the same thing as 3 times 5. So when I'm multiplying these two things together, I can flip-flop them if I wanted to. Okay? And just make sure you box that 10 also, because you pulled that out at the very start. And that is it. So if you have any questions, feel free to stop by during my office hours and ask me them, or email me if you want to as well. Any one of those will work out just fine. Okay. I hope everybody's doing well, and take care. Bye-bye.